Hello everyone. My name is Adam Roser with the National Weather Service in San Diego. We're here for Monsoon Awareness Week across the Western United States. And our topic for the San Diego office is debris flows. So we're just gonna talk a little bit about debris flows quickly, what they are and how you can be prepared for them. So we have meteorologist Bruno Rodriguez, who works at the Weather Service office with me, fire weather focal point there, so he can help discuss fire weather things as well. And then we have Yanni Schwartz here with the Los Padres National Forest. So he's going to explain kind of the BEAR program and how debris flows are assessed. So Bruno and Yanni, take it away on what are debris flows? What are they?
Thanks, Adam. So obviously we're in wildfire country, but an often underestimated hazard can be debris flows after wildfires. And they happen fairly frequently after large fires, and we saw that a few years ago with Montecito. So, Yanni, a question for you, really, just what are debris flows and how do they occur?
Okay, so to answer that, I just prepared a short PowerPoint presentation, and we'll just go through a few slides, and we can start from the beginning. Just with a few definitions. So debris flows occur when masses of poorly sorted sediment, agitated and saturated with water, surge down slopes in response to gravitational attraction. Sediment and water mixture become a slurry similar to wet concrete, capable of holding gravel-sized particles in suspension when flowing slowly or stopped. So this is kind of an interesting point. It just shows you how dense this flow is and how powerful it is. It's so dense that it actually can hold particles like small rocks and gravel-sized particles in suspension, even when this flow is kind of frozen, when it gets to its loses all its momentum and just stops. And then in steep canyons, flow can achieve high velocities, transport large boulders in suspension, and cause catastrophic damage from impact or burial. So when this flow is in motion, it's not only carrying fine sediments and gravel and rocks and all of that material in suspension, it starts picking up large rocks and boulders, and all of that material is in suspension. It's hard to imagine how a large boulder, and I'm talking about sometimes house-sized boulders, are just floating on the top of this flow and moving downstream. And then obviously when this impacts anything on its way, it will take it out. So just to go through a few types of flows that we have out there, we have water flows, which we consider kind of a clean flows. You know, let's say in an urban environment, in a concrete channel, you might have a completely clean flow with 0% sediment. And as it goes, as the amount of sediment kind of picks up in that flow, this is a little bit more murky and a little bit more muddy. When it goes over 10% and anywhere between 10% and 60% of sediment, then we consider it a hyper-concentrated flow, and it starts behaving a little bit different than a clean water flow. But then when it goes over 60% sediment, then it's defined as a debris flow. And then its physical properties and its behavior is very different and very way more dangerous than either water flows or hyper-concentrated flows. So I just brought a few pictures here that we can look at it, kind of the process from the top of the hill all the way down to the bottom. So imagine a fire went through a landscape, burned and removed all the vegetation, and changed the properties of the soil. Now, if you have a rainstorm, and usually the type of rainstorm that we talk that initiate debris flows are short duration, high intensity rainstorms, which are very typical to monsoon rainstorms. Then you start having this erosion features, elongated erosion features on the slopes that you're seeing here, which we call reels. And these reels are starting to flow down the slope, the very steep slopes, carrying all the fine sediments and sand and gravel with them down into gullies. Now this flow is eroding gullies and flowing into larger channels, and eventually it hits like a drainage. In the drainage, it will start picking up all types of material, rocks and boulders that might have been sitting there for decades or maybe hundreds of years. And now the whole flow is picking up all these different types of material and flowing down drainages. And as it's flowing down, one typical feature that we'll find on debris flows is two levees. You can see kind of two elongated rocky levees on both sides of the channel. Those are kind of typical features that we find in a debris flow. And then at the end of the debris flow, where the deposit is finally kind of loses all its momentum and stops, that's where we'll find just a huge cluster of unsorted, non-stratified, and matrix support material. And when I'm saying unsorted and non-stratified, I mean material all the way again from the very fine sediments through sands, gravel, rocks, and all the way up to boulders, again, can be house-sized boulders. All of them mixed together. And again, as they're going down, they'll take out vegetation, trees, roads, bridges, and houses, or will bury them completely. So a very, very dangerous feature that is fascinating for us geologists to study after wildfires.
Wow, thanks for that. That image is amazing, that last one that you showed. And you touched on something interesting. The rainfall rate is absolutely right. I mean, rainfall rate is everything more so than the total rain that falls throughout an event, right? It's just that rainfall rate in 30 minutes or 15 or even 5 minutes that could really trigger. So,
yes.
And lastly, so usually one of the first things that happens after a wildfire is we get what we call a bear team, make an assessment. So if you want to talk to us a bit about that and what that involves.
Yeah, so a bear team is basically a team of scientists, which include the most important, I would say the most important, but actually just part of the team are the physical scientists, which include hydrologists, soil scientists, geologists, engineers, but depending by whatever resources we have out there, it will include also a biologist and a botanist and archaeologist and other specialists that all come together and assess a burned landscape and try to, the first thing that we'll do is we'll try and identify values at risk. And values at risk are considered campgrounds, roads, structures, habitat of an endangered species, and also values at risk that are below, downstream of the burnt landscape, like again, private properties, structures, houses, and whole neighborhoods. So first we'll identify the values at risk that are out there, and then we'll assess the soil burn severity, and we'll look at the geological features. We'll look at the slopes, the type of geological units that we have there, the type of material, types of rocks, how stable these slopes are, how available this material is to be transported if a flow of this nature goes through it. We'll send all of this data to the USGS group that studies debris flows. They'll run their models, and they'll send back to us a bunch of products. The three main products that we'll get from them are probability of debris flows. And this is in every channel. So every channel out there in the burnt landscape will have a probability of it initiating a debris flow under a certain magnitude of storm. So you have different magnitude of storms. As the magnitude of storm gets higher, the probability gets higher. But we'll get all the probabilities for every drainage under a certain magnitude of storm. We'll get from them the volume predicted of debris flow from each one of these drainages under a magnitude of storm. And then what we call a combined hazard, which is basically taking the probability and the volumes and putting them together. And then we'll look at these maps, we'll look at the data that we collected out in the field. Basically, each discipline will write their own report, trying to assess and predict the risks and the danger for each one of these values at risks, especially associated with the first rainstorms that are going to impact this burnt landscape. And then we come up with recommendations of mitigations in order to reduce the risk. So obviously the highest risk, the highest value of risk that we have there is life and property, and life first of all. So, from there on, we'll start working with the National Weather Service on warning signs, closures, evacuations, and so on.
Thanks, Tony. Yeah, I mean, the Weather Service definitely relies really heavily on those bear assessments. We wouldn't be able to warn on debris flow risks without them. So.
All right, great. And then, yeah, I'll share my screen here for a second. Just kind of views that you can, different avenues you can just to go about getting warnings. So when we look at these debris flows, a lot of times they are flash flood warnings. But also in the fire weather realm, we're looking at fire weather watches, maybe preceding when conditions do get kind of close to fire weather conditions, and then also red flag warnings, as you may know, if it's very dry or very windy, that produce those fire conditions. So a good thing is to have multiple ways to get warning. Here's just some information. Obviously, your phone is very important. Those wireless emergency alerts have that feature turned on. A NOAA weather radio is also a good thing to have, especially if you live in a more rural area, and watching your local TV and going online to our website at weather.gov/San Diego. We'll have all the information as well as our Facebook and Twitter pages. So that's kind of a little bit of what we wanted to talk about, and we hope you have a great week, and hopefully we get a good monsoon season.
Hopefully.